Atoms. Everything in the universe is made of tiny building blocks called atoms. Think of them as Lego bricks for everything around you. Structure of an atom. Atoms have a nucleus at the center, which contains protons, or positively charged, and neutrons, or neutral, no charge. Electrons, or negatively charged, orbit around the nucleus in regions called shells or energy levels. Size. Atoms are extremely tiny, around 0.1 nanometers in radius. The nucleus is even smaller, about 1/10,000th the size of the atom. Masses and charges. Proton. Mass equals 1, charge equals +1. Neutron. Mass equals 1, charge equals 0. Electron. Mass equals very tiny, charge equals -1. Atoms are neutral overall because the number of protons equals the number of electrons. Tip for remembering: draw a simple diagram with nucleus and orbiting electrons. Label charges and masses. Visual memory helps. Elements. An element is a substance made of only one type of atom. There are about 100 different elements. All atoms of the same element have the same number of protons. Atoms of different elements have different numbers of protons. Nuclear symbols show the number of protons, neutrons, and mass number. Example: carbon-12 is written as squared C. Tip: think of the proton number as the identity card of an element. Neutrons just add weight, electrons balance the charge. Isotopes. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. The relative atomic mass of an element is the average mass of all its isotopes. Calculating relative atomic mass. Use the mass number of each isotope and its percentage abundance. Multiply mass by percentage. Sum them, divide by 100. Tip: practice a few examples. This is math plus chemistry. Compounds. Compounds are made of different elements chemically bonded together. They are shown using chemical formulas like H2O or sodium chloride. You need a chemical reaction to separate a compound back into its elements. Tip: remember that compounds behave differently from the elements they're made of. Water is nothing like hydrogen or oxygen alone. Chemical equations. Chemical reactions create new substances. Word equations and symbol equations show reactants and products. Learn to balance symbol equations so the number of atoms of each element is the same on both sides. Tip: start with elements that appear only once, balance those first, then move to the trickier ones. Mixtures. Mixtures are combinations of elements and/or compounds that are not chemically bonded. The properties of the substances do not change in a mixture. Mixtures can be separated by physical methods like chromatography, filtration, crystallisation, evaporation, and distillation. Tip: always ask yourself if a chemical bond exists. If yes, compound. If not, mixture. Paper chromatography separates colored liquids in a mixture. You use paper, solvent, and let the components move at different speeds. Filtration separates an insoluble solid from a liquid. Evaporation and crystallization separate a soluble solid from a liquid. Evaporation removes all liquid. Crystallization lets solid form crystals. Distillation, simple distillation, separates liquid from a mixture when boiling points are very different. Fractional distillation separates liquids with similar boiling points. Tip: draw the setup for each method. Visual memory sticks better than text. History of the atom. Early scientists thought atoms were solid spheres. Plum pudding model: atom as a positive pudding with electrons as plums. Rutherford and Marsden's alpha particle experiments showed the atom has a tiny, dense nucleus. Bohr proposed electrons orbit in shells around the nucleus. Discovery of protons and neutrons refined the nuclear model. Tip: make a timeline with pictures. Solid sphere, plum pudding, nuclear model, Bohr's model. Electronic structure. Electrons fill shells closest to the nucleus first. Can show electronic structure using numbers, e.g., oxygen equals 2, 6. 2 in first shell, 6 in second. Learn first 20 elements structures. Tip: use the 2, 8, 8 rule for the first 20 elements. Exam-style questions. Carbon monoxide and carbon dioxide both contain carbon and oxygen. Which term best describes carbon and oxygen? Answer: elements. Question: which term best describes carbon monoxide and carbon dioxide? Answer. Question: write a word equation for the reaction of carbon monoxide with oxygen. Answer: carbon monoxide plus oxygen, carbon dioxide. Balance the symbol equation. Colorado plus O2, CO2. Answer: 2CO plus O2, 2CO2. Question: describe the reaction in terms of molecules. Answer: 2 molecules of CO react with 1 molecule of O2 to form 2 molecules of CO2. Question: what is the charge of the nucleus of a carbon atom? Explain. Answer: +6, because there are 6 protons, and protons have a +1 charge. Question: chlorine atom, nuclear symbol 37Cl. Protons, neutrons, electrons. Answer: protons equals 17, neutrons equals 20, electrons equals 17. Question: a chlorine atom with mass number 35. How are the 2 atoms related? Answer: they are isotopes, Same number of protons, different number of neutrons. Sodium chloride dissolves in water. Is the solution a mixture or a compound? Answer: mixture, because the salt and water are not chemically bonded. Electronic structure of chlorine. Answer: 2, 8, 7. Question: sodium electronic structure. Nuclear symbol 3Na. Answer: 2, 8, 1. Two methods to separate sodium chloride and water. Answer: evaporation, simple distillation. Question: describe Rutherford's nuclear model. Answer: atom has a tiny, dense nucleus with protons and neutrons. Electrons orbit outside. Question: how is the plum pudding model different? Answer: plum pudding had no nucleus, positive charge spread through atom, electrons embedded randomly. Bohr's contribution. Answer: electrons orbit in fixed shells around nucleus.